Introduction. Astronomers have long been intrigued by the possibility of a hidden planet in our solar system dubbed Planet 9. This hypothetical planet could be lurking far beyond Neptune, possibly 5 times larger than Earth. For years, scientists have been captivated by its potential existence, and now new evidence suggests it may explain the unusual movements of icy objects beyond Neptune. But what makes Planet 9 so special? Why does it matter? And what have scientists uncovered about it? In this video we'll dive into the science of Planet 9, explore the latest discoveries and reveal how it could transform our understanding of the solar system. The evidence for Planet 9. First, let's get into the evidence that led scientists to hypothesize the existence of Planet 9. The story starts with strange orbits of objects beyond Neptune known as Trans-Neptunian objects, TNOs. These icy bodies, often inhabiting the Kuiper belt, exhibit odd behavior that defies explanation, unless there's a hidden giant out there influencing them. Back in 2016, Caltech astronomers Konstantin Batygin and Michael Brown observed that several of these TNOs shared similar orbital characteristics. These TNOs follow elongated orbits that bring them unusually close to Neptune, then send them back into the outer reaches of the solar system. If we think of the solar system as a giant disk, these objects aren't just staying neatly within that plane. Their orbits are tilted at steep angles, making them outliers in our cosmic neighborhood. But here's the kicker. These TNOs shouldn't behave like this on their own. Something is guiding them. This strange clustering of orbits, where the objects closest approaches to the Sun and their farthest points all align, led scientists to speculate about Planet 9. This planet's gravitational influence could be the key to explaining why these icy bodies move the way they do. What makes this evidence so compelling is that other explanations, like interactions with Neptune or the gravitational pull of the Milky Way, the galactic tide, don't hold up under scrutiny. For example, recent simulations showed that the galactic tide alone can't push these TNOs into the orbits we observe today. But when Planet 9 was added to the model, everything clicked into place. The planet's gravity perfectly matched the observed behavior of these TNOs. Scientific simulations and analysis. Let's take a closer look at how scientists are testing the idea of Planet 9. To solve this mystery, they've run a series of simulations. Think of it like trying to solve a huge puzzle with millions of pieces scattered across the solar system. Each piece represents an icy object with its own unique orbit. Scientists ran these simulations to compare 2 situations, one where Planet 9 exists and one where it doesn't. In one set of simulations, the researchers modeled a solar system with no Planet 9 and only the gravitational pull of the galactic tide acting on the TNOs. What they found was that under these conditions the TNOs couldn't be pushed past Neptune's orbit. The galactic tide alone was too weak to explain the orbits we see today. Then they added Planet 9 to the equation. In this model, a planet with about 5 times the mass of Earth exerts its gravitational influence on the TNOs, causing them to be slingshot past Neptune. The result? The simulated orbits matched the real-life orbits of the TNOs almost perfectly. This provided the strongest statistical evidence yet that Planet 9 is out there, hiding in the depths of the solar system. What's fascinating is that these simulations also helped rule out alternative explanations. For instance, the idea that these orbits were shaped by a past encounter with another star doesn't hold up under the data. Similarly, the possibility of a small black hole influencing these objects seems less likely given the strength of the Planet 9 model. By comparing different scenarios, the researchers concluded that Planet 9 is the most reasonable explanation for the strange behavior of the TNOs. This suggests that we still have much to learn about our cosmic neighborhood. It would be the first major planet discovered in our solar system since Neptune in 1846. This also opens the door to new questions about the formation of planetary systems in general. Planet 9 exists, how did it get there? Was it captured from another star system, or did it form in place and we're only now discovering it? Previous evidence, similar planets, and habitability. But Planet 9 isn't just a theory built on recent evidence. Its origins stretch back to earlier astronomical puzzles. Long before Batygin and Brown's work, astronomers noticed oddities in the orbits of objects like Sedna, a distant dwarf planet with an unusually elongated orbit. Sedna's orbit couldn't be explained by the known planets, which hinted at the gravitational influence of a hidden world far beyond Neptune. Interestingly, the idea of a hidden planet isn't unique to our solar system. In other star systems, astronomers have found planets that influence their surroundings in similar ways. For example, some exoplanets have been discovered because their gravity tugs on nearby objects or distorts the light from their parent stars. These so-called perturber planets share similarities with Planet 9, providing a fascinating parallel between our solar system and distant worlds. This planet could teach us valuable lessons about the limits of habitability in the universe. Even if Planet 9 isn't suitable for life, studying its characteristics could help us better understand the kinds of environments where life might thrive or struggle to survive. As we await further observations from the Vera Rubin Observatory, the prospect of finally uncovering Planet 9 remains interestingly close. Outro. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more exciting space updates. See you next time.